welcome everyone. We're at the top of the hour here, so we'll get started as folks come in. Welcome to this month's PHN Presents on Passive House and Resilient Design in the Face of Fire. We're really happy to have Andrew Mitchler here of Hyperlocal Workshop. My name is Ken Levinson. I'm the Executive Director of the Passive House Network, and I want to welcome you. The Passive House Network is a national nonprofit. We are really focused on knowledge sharing, community building, training, and helping each other build successful Passive House projects and grow the ecosystem. We are affiliated with the Passive House Institute in Darmstadt, Germany, and the International Passive House Association, work closely with the North American Certifiers Circle and all the various Passive House groups around the world. We encourage you to become a member, help share the global knowledge, help apply it to regional contexts and local applications. As I mentioned, we're really about education because we think and know that education is really what changes our vocabulary. It changes our conversations. It changes our expectations, how we think and work around buildings. And so we've developed a whole pathway of education around Passive House, beginning with introductory courses. We're very happy to work with Building Energy Exchange, to core certification courses, the Certified Passive House Designer course, as well as the tradesperson course. So we work with EMU Systems out of Colorado for that tradesperson course. And then advanced specialized courses. And we like to think of building certification and the certification process really as an integral part of a professional's education, that by going through that, you just learn by doing so much, and the institutional knowledge that you benefit from in the certification process. Coming up on Thursday, if you're new to Passive House and want to take a bit of a deeper dive, this Thursday, April 14th, is a great introduction to the Passive House Standard course. Encourage you to check that out on our website. And then starting at the beginning of May, we have developed regionally focused hybrid online, on-demand, live online, and in-person certified Passive House designer courses coming up, focused on Colorado, Massachusetts, and New York. The course is also available on demand at any time from around the world. You can plug into it. So we want to make it accessible and as affordable as possible. A couple of other quick announcements here. A week from today, we have the first installment of what will be a new series called Ask the Passive House Certifiers, to make the certification process more accessible and open, to be able to bring questions, to be able to speak to the certifiers and hear from them about what matters the most, and to be able to make those processes work better and more smoothly, and to know what to expect. So certification, again, incredibly important. Encourage you to join in. And then 2 weeks from today, we have a training on the pH ribbon, which is the PHPP, the energy model of Passive House, add-on to do total carbon calculations, so that we have the energy model from the PHPP. We can then deduce carbon emissions from that, and also add the embodied carbon calculation of the building to have complete emissions profile of your design and have total control and really be able to drive it down. So we're really excited. We're just rolling it out this year and encourage you to participate. And finally, I think in terms of events, we have our conference coming up in Boston. It will be happening online and in person, a hybrid event. Online only on June 10th is the first part, Friday, June 10th. And then a week later, Friday the 17th, it will be in person in Boston, but also broadcast live remotely online. So you don't need to travel to Boston, although if you're inclined to, we would love to see you and meet in person again. Early bird registration is now open and ends on April 22nd, at the end of next week on Earth Day. So in celebration of Earth Day, make sure you register for the conference. We want to thank our sponsors, without who we could not do this. They are really integral parts of this, and along with high quality education and training and knowledge sharing, high quality components are critical to Passive House success. And so we're really happy to work with manufacturers as well as service providers in making those more available and in the context of learning here. So in insulation, Owens Corning, Rockwool, and Aero Aggregates. The enclosure systems, 475, Rotoblast, and Partel. In HVAC and more specifically ventilation systems here, we have Zender, Swagon, Ventacity systems. Windows and doors, Alpin, Cascadia, Enersign, Intis, Stucco, and White Windows. And finally, the service providers, Bright Power, AHA Engineers, Need-Based Architects, Stantec Architects, Stephen Winter Associates, NYSERDA, Cube 3, and Cranshaw Construction. So thank you again to the sponsors. So welcome to this presentation. We're really happy to have Andrew back. Wildfire resilience and the growth of wildfires are of ever increasing importance. And we've seen in devastation in the West in particular, in various areas, including the Marshall Fire in Colorado over the holiday season this year, just being absolutely devastating. And so how can Passive House help support greater resilience in the face of wildfire? We're really glad to have one of our own, Andrew Mitchler, as quite an authority and growing experience, for better and worse, around wildfires. Andrew has focused on high performance building design and materiality since 1993, is the author of the book Hyperlocalization of Architecture, which I should say is a great book. I've got it right here. It's a gorgeous book and super insightful, and it's available online. Go for it. He's also the principal of the design group Hyperlocal Workshop. He's co-founder of Passive House Rocky Mountains, a chapter of our network, and it's a great chapter, very vibrant chapter, and has served as chair of the Northern Colorado Renewable Energy Society. He completed his first international certified Passive House in Colorado in 2016, which has won several awards and has been prominent in the international design media. He has experienced multiple fire events, including the 1991 Oakland Hills Fire, and in 2020, the Cameron Peak Fire, the largest wildfire in Colorado to date. He is currently working on the rebuilding effort for the Marshall Fire in Boulder, Colorado. So welcome, Andrew. I am going to stop sharing. And as we switch over, I want to invite everyone to put your questions into the chat. When Andrew's done speaking here today, we will, I'll be having a discussion with him, asking him questions, and we want to feed in your questions into that discussion. Thank you, Andrew.
Yeah, thanks, Ken. Thanks for inviting me to talk about the unfortunately very topical subject lately of fire resilience in buildings. And I guess we've been giving these talks quite a bit in Colorado because of the not the Cameron Peak Fire, the Marshall Fire, which happened in late December in Boulder. A lot of you probably heard about that. And I think about 1,000 structures were lost. Entire cities and communities were basically wiped off the map in a matter of hours in a fairly built up area of the state. So I think it came to quite a shock to people how incredibly vulnerable we are because of our built environment and housing stock, and the threat of fire in the face of that. And also, as Ken mentioned, it's not really new to me. My family lost our home in 1991 from the Oakland Hills Fire, and a lot of people burned in about 5 days. And unfortunately, about 30 so people lost their lives in that fire event. So that's kind of where I began my building career. Was I left college and helped my dad rebuild after that fire, and discovered that I loved tools and I liked building. So I've been doing that kind of ever since. Right now I live, my passive house is right on this map, as you can see, and this is to the left is the Cameron Peak fire, which happened 2 years ago, about in the summer. And this lasted for about 3 months. This is Colorado's largest fire, 200,000 acres burned. And this particular fire met up with another fire that burned 90,000 acres about 8 years before. So this is the absolute new normal for here in Colorado. And as we know, in California, in Canada in the West, BC, that fire is here to stay at the scales that threaten entire communities. So we have to learn. We've always talked about learning to live with it, but I find that our buildings were not designed for fire. So I'm going to go quickly through some of the thoughts I've had from my experience of building in a fire area, and some of the detailings and thinking behind my specific passive house for fire resiliency, and seeing if we can broaden that out in scale and talk about kind of the conditions of Firewise construction and how that works with passive house and the physics of passive house. There's quite a bit of connections between those two types of thinking around building. So dive into some of the specifics. Quickly, almost all the projects I work on are in WUI areas. That's the wildlife urban interface. And what that means is basically either places that are in forest or at the edge of forest, either communities or a single family that is within kind of a heavily wild area. Heavily wild area, I don't know if that's a term, but as we discovered in this last fire also, that it could be entire communities just in grasslands that could be threatened too. So all my projects have to think about fire quite specifically. Actually, I do have one in New York. I don't know if you guys have wildfires in upstate New York, so maybe I can use a little more wood than I typically can, but most of the time I can't. A lot of the conversation around why we're talking about passive house here for the rebuilding for the Marshall fire is because Excel Energy is providing a $37,500 rebate if you build to a certified passive house, which is pretty unprecedented. And that has a lot of people talking. It's really got the attention of the local government communities, as well as lots of individuals. So we've been working a lot with the Colorado Green Building Guild on providing resources and doing a lot of talks on what passive house is. Because I think a lot of people are going to ask their local builder or their local architect who has no experience, can you do passive house? And they'll probably say, yeah, sure. And then now we have to figure out how to get that from the acknowledgement into an actual practice. So we're doing a lot of work on the back end to make sure that this is as smooth a process as possible. So this community will both be a carbon ready, essentially, community in the future. So in terms of fire, I'll read this article that just came out a couple months ago. Researchers discovered in 2008 the newer home is about 16%, percentage points, 40% less likely to be destroyed than 1990 home experiencing identical wildfire exposure. Strong evidence that conclude that these effects are due to state and local building code changes. First, after the deadly 1991 Oakland firestorm, again, the strengthening of wildfire codes in 2008. They observed vintage effects are highly nonlinear, appearing immediately for homes built after building code changes. There's no similar effects in areas of California not subject to these code changes, or in other states that lack wildfire codes. So this is one of those things where we see a direct and very powerful correlation between what we build and their vulnerability to fires. So that level of insight is really, really quite powerful in the sense of not just individual buildings, but in community design and code. Right now, code is relatively weak. Your standard code is going to require maybe 5/8 drywall between the garage. You have to insulate the buildings anyhow. You have to typically put in smoke alarms, and then maybe fire blocking within the wall system. And probably the most aggressive thing we see now for most code built houses for wildfires, using a roof class A type of roofing material. So that's typically one of the more vulnerable parts of the house, but fire gets into a building in multitude of different fashions. So when we're looking at wildfire conditions, just a fire resilient roof is certainly not going to be enough. So how does that work within the context of passive house and the physics of buildings in general? Well, look, it starts with the simple shape of the building. And we know famously, passive house, we talk a lot about form factor. Turns out that form factor, or a simplified amount of wall to floor ratio, or reduced floor to wall ratio, meaning that we reduce all these kind of bumps and edges to the building, and that reduces the fire impact of the building when a fire conditions come by. And here's a good graph of what happens. Often in a wildfire event, the first thing that happens is you get embers coming into the building space, and your building is most vulnerable by these embers when they lodge into corners, when they lodge in underneath cantilevers or onto corners with decks or eaves, things like that. The more complex the building is, the more places for small fire conditions to evolve into larger fire conditions that can get into the structure of the home quite quickly. And even underneath solar panels, for instance, which is, sure, we have a Class A fire roof, but if we have debris in underneath of a solar electric array and we can get embers into that, then that can burn right through the roof system in roof substrate into the building itself. So form factor is kind of that first defense against wildfire vulnerability, and also, of course, saves quite a bit of energy. I have a slide a little bit on how form factor works in passive house later on. I have the second real serious condition to look at for wildfire resilience is to look at around the house. That we're looking at, they call it defensible space, kind of in the WUI world, but it's in kind of in a more urban setting. We're also looking at plantings, we're looking at fences, wooden decks, all sorts of kind of conditions right next to the building that essentially act like a wick. So if the deck catches on fire, that becomes like setting a bunch of twigs on fire right next to your building, just like you would start a small fire, like a small campfire. Think of it in that terms. If a fence burns, that fence can burn right up to the building. So eliminating that condition right against the building. Certainly the plantings next to the buildings like junipers or other highly flammable evergreens, and decks, railings, all these kind of small conditions right against the building make the building much more vulnerable. And then as further out, we look at the Firewise Landscaping conditions. So the first 5 feet or so are typically wanting to be more hardscaped than not. Here's some nice pictures of how people deal with that. So minimal plantings around the immediate area of the building, and using plantings that are not prone to support fire, clearing up pine needles and leaves and stuff like that before summer happens or spring. And then keeping clear. I live in forest, so this is more important to me than maybe in other places, but keeping ladder fuels from going into tree canopies and spreading that way is something else. So landscape is a critical component of that defensible space, so to speak. And so that defensible space also extends to neighbors. So you're looking at making neighborhoods a defensible space, and we call this Firewise Neighborhoods. And that's actually something that unfortunately is not necessarily codified, but is something where neighbors often get together or can get together and create a shared defensible space throughout the entire built environment between them and the wildlands that they border against. Even though that's a little more complex to organize on an individual basis, it's extremely effective when we look at it being implemented in vulnerable communities. So when we get back to the buildings themselves, there's some interesting things about for instance, how I've been working with Passive House in my assemblies, and assemblies that we're seeing quite often now with Passive House turn out to be extremely fire resilient, happily. That starts with reducing, or I should say in this case, eliminating the way for embers to get into the structure itself. So as we can see to the right-hand side, that ventilated roofs are extremely vulnerable as you get firebrands that can get in underneath the eaves and lodge themselves into the roof itself. That creates the perfect condition for flames to spread and burn essentially the house from the inside out. It's the same condition for crawl spaces, if crawl spaces are implemented. There are products out there that help reduce this vulnerability, but still create a ventilated roof. But I actually prefer just to get rid of the entire problem in the first place. With Passive House, we can, with unventilated roofs that are properly detailed so that we have good moisture management and condensation management within the roofing system that also eliminates the possibility of getting overly heated air, saturated hot air, and embers within the roof cavity itself. So minding those gaps. The second amazing place where Passive House aligns brilliantly with Firewise construction is the windows. Windows are extremely vulnerable to fire. They crack from the heat. And so the second thing that comes along in a fire event is a heat front. First you have your embers, and then you have this massive heat front. You can imagine if a house is burning next to a structure, or a large grass fire, or trees on fire right in front of the building, that heat can actually crack windows. These kind of cheaper window frames can fail. We've seen out here where I live, we've seen concrete houses burn no problem, simply because the glass in the buildings failed relatively quickly. So now when we look at Passive House, typically, of course, we're using triple pane windows. Our frames are much more substantial. And add that with tempered glass, you have much better protection than what traditional code compliant housing requires. I don't know of any fire resilient codes now that look at glass outside of just providing tempered glass. But they say, like in a fire front condition, you add about 5 to 7 minutes per pane of glass. So you can double your protection from a triple pane system compared to a simplified double system for vulnerability from the heat front. And then, of course, what most people are familiar with for fire resilient design is the materials on the building. Roofs are pretty obvious. Asphalt, just typical 3-tab asphalt roofs are considered fire class A. But metal roofs are becoming much more popular. They're a little bit more, a little more chic in some conditions, depending on what's your architectural preference. But there's a lot of metal. There's metal roof options that look like slate. There were cementous options that look like slate, or I should say wood, cedar, shake. Probably the most popular that we're seeing, of course, is hardy board or fiber cement boards that can look like shake, or they can look like just simple lap straight. For now, they're coming in sheets and more contemporary design, so they're being more architecturally interesting. Stucco is certainly really quite popular. Brick is very vernacular and very effective if it's protected the back and where breeze is protected as well, so we don't get embers behind the brick and the structural wall. And of course, stone. So, basically no wood is a good place to start, especially when we look at like cedar shakes, things like that, things when we have cedar down to ground conditions. So the cedar can take that ground condition fire that's burning at maybe a plantings or something close to the ground, and basically ladder up into the wall system through the wall. And then it's more than skin deep. Foams are, foams, even though they quote unquote put fire resilient resilient materials in them, foams typically burn extremely well. I think it was Lloyd Alter who used the term solid gasoline. When it gets going, it's nearly impossible to stop. So avoiding foams for fire resilience is kind of a first option. Fiberglass actually is not typically really great for fire resilience either, because it's quite it lacks a density to it. So there's a lot of air movement potentially within fiberglass bats, which means that if a fire does start within the wall cavity, it has oxygen available to it, no problem. So we're looking, typically the first product people talk about is mineral wool boards or bat, stone wool as well. And those are pretty much fireproof, technically speaking, at least within the conditions of a fire event or house fire event. Cellulose is surprisingly very effective within fire conditions too. They do use borite within like 15% borite mixed in it, that it will smoke, but it won't carry flame at all. And because it's called dense packed cellulose, means that it's choking all the oxygen out from the wall cavity. So there is no opportunity for fires to get that much oxygen when they're within the wall itself. So that's a kind of a secondary defense strategy. And then when we're looking at, I'll go into a little bit about the details of what I was thinking when I was designing my place. I think it was around 2014 when I first started designing this passive house. And you can see it's in a heavily wooded area. Right across the way, we had a fire in 2001 or so, about 10,000 acres that I stared at for days and days, watching that thing burn. So that's when I really knew the fire was kind of the primary condition to try to design around and with. And if we can build buildings in harmony within WUI areas, then I thought that made a lot of sense as a proof of concept. So I went pretty crazy. I decided to build a typical framed wall, typical kind of passive house Larson truss assembly system. So you build a structural wall on the inside, and then I skinned it. That's my air barrier, is in this case the plywood, which is also the shear wall. And then I put in Larson trusses, which are basically like I-joists. They're like homemade ladders, and they're just cavities to put lots of insulation in. Colorado, of course, we need lots of insulation, at least in smaller houses. So on the outside of that is where I really started thinking about the fire resilient design and used a mineral wool board, about 2.5 inches of that. And then the cladding, which is mostly fiber cement on the outside of that, or steel. And then some wood accents and some protected areas. But between using the interior wall cavity was a mineral bat, and then the dense packed cellulose, which is about 4 to 4.25 pounds per cubic foot, and then the mineral wool board. We're looking at a extremely fire resilient building. And the reason why I say fire resilient is because there is no such thing as a fireproof building. Even if the building survives in hot enough a fire condition, the contents themselves can catch fire inside in the most extreme events. It's pretty much impossible to build fireproof. But fire resilience is basically, think of it more like gambling. You're trying to just build your odds up because fire conditions can be radically different when it comes to a building in all sorts of different scenarios. And in fact, on our mountain, we thought we were the most vulnerable side of the mountain with the size of the trees and how we were kind of upslope and upwind from the valley. But the spot fire actually started on our mountain on the top, and the winds blew down the other side and basically torched about 8 or 9 houses. And then the remaining houses were vulnerable from the back burn coming up. So it really depends on the conditions, but the odds of a house like this surviving those conditions are significantly higher than a code built house. Even codes here still are fairly minimal for fire resilience, to my chagrin, after a decade of substantial housing losses within the community. We're seeing fire codes change to the point where maybe they're talking about a fire class A wainscot around the building at 3 foot. This is about the most I've seen fire codes change. Maybe there's more than that, but it hasn't been substantial enough yet. And then looking at kind of the carbon process of buildings, we're looking at not just passive house, but kind of the whole carbon question for buildings. So a good friend of mine, Bjorn Kierhoff, developed these Cocoon straw panels. They're mostly in Europe. There's projects that are popping up in the United States as well. And for instance, I bring this up in the fire conversation. Not only are they positive carbon sequestering building materials, but they're very fire resilient. And that's the first thing every smug Twitter comment, whenever we see Echo Cocoon being shared on Twitter, is, oh my God, that fires will burn these buildings down. We found in even straw bale housing, there's something called the Sunshine Canyon fire in Boulder that was a number of years ago. There was almost all the houses in the valley burned, but there was one house that survived, and it was a straw hay house. And the reason is similar to the cellulose situation, is that a straw is not rarely burns in itself. It's mostly silicate, so if it's just a strand, it tends to burn. But it's bunched up, it doesn't hold fire that well. And when you pack it really quite densely, as say in the Echo Cocoon panels, they don't support oxygen. So that makes it harder to burn. And then when you put a fire resilient material like a gypsum, 1/2-inch gypsum, or they prefer clay finishes on the interior for just for the natural quality of it, you're talking about from 190-minute rating to 120-minute rating under extreme fire conditions. So fire resilience is in the sense, it's very much about the assemblies and not just the individual materials. And we can build with all sorts of different materials that typically were not considered necessarily fire resilient, but turn out to be, in the right combination, be extremely fire resilient. Bjorn was talking about how the structural timbers burned before the actual straw burned in their panels as far as when the panels started failing. So smoke. Smoke is something that even if a fire condition is not happening immediately at the property, tens and tens of thousands of people immediately around fire events, especially in more urbanized fire events, are directly and very powerfully affected by smoke. BC's seen this. You guys in California have seen this for the past couple of years. We've seen it in Colorado. That smoke within the building itself, what we call IAQ in this indoor air quality, is significantly diminished. So the first, of course, line of defense is, of course, the airtightness of the building. That's goes without saying. It's typically not well understood within code building practices. In a passive house, of course, it's something we obsess over. And then we know that ventilation, having balanced ventilation with a very high air tightness fabric, work hand in hand with each other. That means that we have controllability of the air system within the building, meaning that we can filter the air coming into the building. So this is not just fire particulates, which can be significant, and I'll show a slide where it's very effective, but also long-term when we talk about general IAQ issues in urban environments. In Colorado, I know our summers are getting substantially worse around ozone issues and particulates from burning, from fracking, from pollen issues, things like that. In fact, it's gotten to the point where in Australia, where they've seen good 2 decades of significant bushfires in Queensland and other areas, that they're looking at passive house air tightness as being a primary source to protecting your home when it comes to fire resilience. So it's really great to see how the kind of the methodologies of passive house is stretching out into these other kind of scenarios of survivability and quality of life for people around fire events. In Canberra, Canberra is right in the middle of, it's right in between Sydney. It's the capital of Australia. It's right in between Sydney and Melbourne, and very forested area. So somebody who built the first 2 certified passive houses there, they're very similar houses. And he did some testing a couple of years ago, or maybe it was last year, a couple of years ago, around IAQ in fire events. And so he monitored them quite carefully. And we'll see that in the first chart, blue is the outside air quality in the parts per million. And the 24-hour threshold is the recommended health threshold for fires, that dotted line at the bottom. So we're way, way over that kind of normalized, considered healthy threshold for particles per cubic meter in the air. The red line is going to show what a leaky house, or what they're all leaky in Australia. Air tightness is not really a thing. So we'll just say a code standard house in Australia was just minimally better, nominally better than the exterior conditions, with all windows closed, doors closed. So essentially the houses were not protected from fire events whatsoever. And for a airtight home, for a passive house, normal passive house, in this case, it reduces the smoke particulate concentrations by 1/2. But as we can see, that's really still well above that dotted yellow line. So what he did was he put in a dedicated a MERV filter. I can't remember, or I'm sorry, HEPA filter in this case. Filters are kind of complicated. They're not great how they're rated. So we're going to say HEPA is going to be maybe, and somebody in the audience probably knows this much better than I do, maybe like a MERV 8 or 9, I'm thinking, filter, which is quite good. And once in that fire, in another fire event that came by, when outside it was 400 count for the cubic meter concentration, for a again for a typical passive house, it was about half of that. But when they put the filtration system in, it effectively got that air rating most of the time below the 24-hour threshold for what's considered healthy air environment. So we're looking at the controllability is key to smoke conditions. And Mark Attard, who is a passive house builder in the Marshall Fire, his house was right next to the edge of where the fire burn was, and he did a significant passive house retrofit and put in balanced air, ERV, and put in a filtration system. And his house had a little bit of smoke, but pretty nominal, while every neighbor in his neighborhood had significant smoke damage. So he was basically the only person who could move in back to his neighborhood, even though the other neighboring houses were intact on his side of the street. The smoke damage was so severe that either they have to mitigate it or they have to tear essentially most of the interior of the houses out and replace it, while he survived it. Let's get into form factor for passive house. So tree of four, we'll go through this pretty quick, but I want to show how it really impacts the overall way that we build houses. So TFAs, think of it as like the exposure of your surface area to the exterior conditions. And we know that quite personally, when it's wintertime, we're wearing a pair of mittens. For our fingers, our tips are exposed. Of course, that's a non-insulated or code insulated house. But if we insulate it and we still have a lot of surface area, we know that our fingers can get cool pretty quickly. So that's why we like to think of them as bundling them together and reducing the overall surface area. When it comes to passive house, we can mitigate that. We simply, so for a very basic, simple house, we can build that, but that's not necessarily architecturally interesting at the same time. So as we know in the PHPP, the Passive House Plan Package, that we can often maybe make a slightly more complex shape. We just add more insulation. But as we see, once we start creating those very small kind of bump outs from the building, it dramatically reduces the energy savings as well. So the kind of finding something between the first rectangle and the second kind of offset rectangles is well preferable to the third option, where we create a much more complex building and much less fire resilient building, and also requires much more insulation and cost as a result, not to mention the building costs. So the more simple, the more cost effective, the higher the performances, the more fire resilient. Just looking at some of the kind of interior conditions I worked for my building for the air tightness. Let's look at the ventilation system. Sorry, it's a little bit more in my slides than jumping in between the kind of what is a passive house to what is fire resilience. So in this case, this is a project that we have underway in Colorado Springs. I'll get into more detail. But the ventilation system was great simply because dedicated ventilation systems also protect the inhabitants for exterior pollutants, as we talked about, and interior pollutants. So we're getting rid of kitchen exhaust fumes, fumes from bathrooms or storage areas, as well as dedicated kitchen ventilation. And it gives bringing up this particular slide because the occupants during a fire event should just shut the system down, essentially. They have controllability at that point where if it gets really smoky for 2 days, which is quite common, you can just shut your ventilation down. So you don't have to really worry about those outside particulates. We can survive a couple of days in an airtight home pretty well with a little bit of elevated carbon dioxide. Just don't fry your chicken dinners maybe at that point. But it gives you that ability to protect the home through the controls of the building. Jumping around back to the fire materials exterior side, here's a project I completed on a neighboring passive house next to mine, where we used fire resilient materials and architecturally, again, somewhat simplified the house, but also used a lot of ways of protecting the house from both front burning from the uphill side and from the back burning side. So it's a little complex in the side. We'll say is that on the back side of the house, where you see in the lower section, it's just concrete and steel, because we're finding is that fires that back burn are actually much more lethal than fires that front burn, or I should say they're different conditions. So from the front burning, you're looking at like a fire event that's like a wave of heat and embers, but they typically burn quite quickly and snuff out. But the back burning conditions can burn much deeper into the ground and right up to the building envelope. So you almost want to think about two different fire conditions that happen. In this case, we can get away with cork. It's a fire resilient material. It's considered a fire B rated material. And with a fire resilient substrate, it's actually quite fire resilient. It doesn't hold flame very well. So it can take a big fire front. With the Firewise folks did quite a bit of experimentation that even if you have a gigantic forest fire in front of the building, wood typically does not self-ignite. It needs an ignition source right adjacent to the materials. So we can control that in the front of the building. In the back of the building, when it back burns down deeply into the roots and the materials, the pine needles, grasses, things like that, that's when we're more susceptible for ladder fueling into the building conditions ourselves. So of course the triple pane windows, things like that are significant. Having a roof that doesn't ventilate underneath is the same conditions that we're building for this fire or for this building. And we're taking those same details and doing them with the Colorado Springs project. I showed the ventilation system earlier. In that case, Colorado Springs has lost neighborhoods before, so they don't let us use any wood outside. So we're simulating wood lath, I should say. We're simulating a wood exterior using hardy board siding materials. And so even though the renders look like they're wood, they'll be cement fiber. Again, our roofs are unventilated in steel. We have to do a landscaping plan that is quite aggressively fire resilient, using massing of materials away from the building, as far as wooded materials or plantings, and then fire resilient landscaping, patio, lower floors cement-ish, and then we're using a synthetic decking on top. And then when the other houses that are built around the building are built to similar conditions, where you have fire resilient neighborhoods. So so one house, typically what Colorado Springs was, they're losing entire neighborhoods. It wasn't the wildfires. It wasn't just like grasslands or trees. It was one house setting the next house on fire, setting the next house on fire. So we're looking at fire conditions that are deeply reduced by the design of the individual houses in union with each other. A project that Brownell and Barry is working on in Monterey is I'm showing you this sheet as to the new rules and regulations for WUI areas within the state of California. And in that case, this particular house, it's hard to read what the conditions that the wall assembly is, but essentially the first 3 feet is a fire class A material that's totally fire resilient. It's going to be steel, but above that, she's able to use wood accents, thicker types of 1-inch plus fire treated wood siding materials. And these are also pretty weather resilient in a kind of marine, semi-marine environment. So it doesn't have to be wood or no wood. There are options depending on the vulnerability of the site. So it's not necessarily an either or. Again, we're looking at the vulnerability reduced by the triple pane windows. Even in a climate where we don't need triple panes necessarily, they're quite effective. And again, the roof system where we're eliminating the ventilation in the actual building roof cavity itself. And then again, certainly Passive House goes well beyond just fire resilience when it comes to the overall survivability of a building. Certainly during fire events or other like extreme weather conditions, actually in California, we're seeing this happen all the time because of fire. They're shutting down power systems as a result. We're seeing that in Texas from those super cold days where, again, the grid's overwhelmed by weather conditions. So the survivability of Passive House is quite extraordinary. Last winter, something called Passive House Challenge was proposed by Mark. Mark, I'm going to forget your last name right now. I'm sorry, but basically he asked a lot of people in the Passive House community to shut their heat down for a week in the middle of winter to see how it responded. And it turns out that my house, my Passive House, the water lines froze coming into the house. I didn't really think about this, but my hydronic heat system failed as a result because I didn't have any water to circulate through the house to heat it up. We had some guests at the time who were writing an album. I'm showing this near, you should check it out, daisydaysmusic.com. And in the middle of their stay, the heat went out in the Passive House. And of course, outside it got to like -19 at night, which got me pretty worried about their well-being. So we didn't have heat for a good week or so. And they did pretty well without a heating system. It got down to the upper 50s, I think, but they soldiered on. They actually seemed to quite enjoy it. And so we were able actually got, is it Tim Conley, to talk about this at a TED Talk. And he's the editor of Passive House Plus magazine in Ireland, England. And we got to kind of share their experience of the Passive House in these vulnerable extreme conditions that they're quite livable. Smoke events, no power events, super cold events, extreme heat events. We really need to be talking about these kind of conditions is why we built Passive House beyond the comfort or the energy side of it. These are quite real and they're hitting these neighborhoods in a big way. And then the kind of the net zero thing, we want to build carbon-free buildings. So we need to look at, this idea of, well, why don't we just electrify buildings? Turns out in winter, we need a lot more energy than we can produce in the foreseeable future with renewables. So Passive House reduces that gap between the renewable energy production and the energy that we need in wintertime. Throw in some batteries and slowly improve the energy capacity of storage and production in the winter. And that gap is reduced significantly to where we can talk about true net zero buildings. And this is just a quick chart of what the Passive House Institute's been helping us. We're designing houses of the future that are based on conditions that are genuinely net zero meta, or I should say macro sized grid situations. So We're building for all these conditions all within one system. So I want to throw that out there. And Passive House Rocky Mountains is our website. And we have a link to where the Passive House Network has put a fantastic page together for fire resilient design. And we'll put up more information on fire resilience as well as Passive House in the coming months. So thank you, Ken.
Great, thank you, Andrew. Great presentation. We have some questions. Let me see if
I'm going to stop sharing, Ken.
Add spotlight. There we go. So wonderful. I mean, it's amazing how Passive House tracks, the methodology of Passive House tracks with doing Firewise construction in all these different aspects. I have some questions to ask regarding all of that, but we got a number of questions from the audience that I think we want to make sure that we tackle here as we go through. I think one of the one that jumped out at me was this idea of the house as a refuge, and we've seen like how it can withstand and minimize the smoke damage. Is there any recommendations that you know of in terms of staying or fleeing?
Don't do it. Don't stay. Do not stay.
Right.
These are fire resilient buildings, but we did lose a Passive House in that fire. And it was a straw bale. It was a straw house. And it met all these criteria that I'm talking about. Brian Fluence's house.
In the Marshall Fire.
Marshall Fire. And that burned, one of the first houses to burn. So you're not, Australia had a shelter in place policy for a long time because they kept finding when people were trying to escape their fire and outrun these bushfires, they're getting caught in the bushfires. And then so they had a shelter in place policy for a long time. And then people started dying in their houses from bushfires. So it's definitely not something, even people are talking about put sprinklers outside. What happens when the water main lines stop? That happens all the time in fire events. What happens when the power goes out? You know, there's all these kind of places where we can design for these conditions, but we can still be overwhelmed by them. And we're seeing the fires just much more extreme than have been seen historically. So it's not worth it. You're not going to.
Right.
And thank goodness we almost nobody died. I think 2 people died in the Marshall Fire. And a lot of people escaped because they definitely knew that this was a major event that was not survivable. So
yeah, I mean, maybe a way to think about it too is like the hurricanes, right? When the call comes to evacuate, you get out because you can be overwhelmed, even if you think you're safe and can ride it out. It's just
yeah,
we don't know.
Yeah, I mean, Mother Nature and physics only take us so far. Then we can only build so much. Yeah.
Yeah, along those lines, in terms of protection, I mean, it was interesting about the materials and the assemblies. I want to dive into that a little bit. There was a specific question on the roll down shutters, fire resistant shutters, available, common. What do you see out there happening with that?
They're super expensive. So I remember back in the day here, after we had a fire like 8 years ago, and they're rebuilding, and nobody knew nothing about how to rebuild for a fire resilient house. Like we had zero information here, and so everybody was talking about, well, we need shutters. So the shutters were extremely expensive at the time, and so nobody talked about the windows themselves, which I always thought, well, okay, we put $3,000-4,000 into the shutter, you'll get the same level of protection as you would a high performance aluminum clad tempered glass Passive House window. So it turned out, you know, you can definitely do both, but I definitely do the high performance windows first and then go for shutters after that. So set your priorities.
Yeah, exactly. And don't definitely, it's hard enough to get that into everybody's mind that the investment in high quality windows is so important in passive house, to then try to compromise that is would be a shame. So it's a good message to hit home. And then in terms of external shading, that maybe the external shading, is done in a way to minimize fire spread, but is not going to be your fire stopper.
So what it will do is all it's doing is, so fire comes, and I didn't really get into the physics too much because we didn't have too much time, but the first thing that happens is first the embers, as I talked about. So you get the spot fires, and then you get a massive heat front. And that's when the windows are failing. So the blinds will protect the windows from that heat front.
Mm-hmm.
That's primarily what they're doing, is just an opaque surface to reduce that huge radiation.
Right.
But if your
Getting
windows are also,
force.
So.
There's a question that just came.
I guess, once we understand the physics of what we're protecting against, then we can look at what our options are and find the right technologies for those options in that condition.
Absolutely. So a question came up, follow up on that regarding the windows and the glass. Are all the layers of the window tempered, or are we just talking about the exterior typically?
I don't know. For codes, typically the interior that can be tempered for safety. And
right, depending on how high it is off the floor.
Yeah, so I do the exterior and interior tempered.
Mm-hmm.
In the middle one's not as important for tempered glass. It does reduce your solar heat gain coefficients as well. So there's a balance there for high performance windows. So
right.
And they're heavy.
The tempered windows, sure. Yeah. So on top of being triple glazed.
I think this guy right behind me, I think it took us 6 people to install this. Doesn't look big. Oh my God.
It helps to have a lift.
Yeah.
But yeah, or a good team. I think let's jump a little bit. We can circle back around here, but into the materials a little bit. We talked about straw, cellulose, the dense packing, the density of the material is so important in terms of its fire characteristics. Yeah. There's a question on using mycelium insulation, fungus, mushroom insulation.
I have zero experience.
Any thoughts? No experience.
I mean, insulation works because literally you're trapping air in it. So it's pretty specific. We'll find out.
And it's a density, right?
Yeah, I've never. Ken, have you ever seen mycelium project? Have you seen it applied? I
have not seen it applied.
I'd be interested because we're working on a bunch of passive house cabin projects, and we're looking at all sorts of different options with insulation materials. So mycelium was on the list. So
yeah. Well, you had cork on the outside of the house.
Yeah. Cork's pretty amazing. I was surprised at how fire resilient it is as a rated material, especially applied against a solid substrate. It's really neat.
Yeah.
Cool.
So along these lines of the assembly and protecting against embers going into assemblies, into roof assemblies, wall assemblies, window assemblies. And there was a question related to that. Maybe speak a little bit about some tactics there, and also folks were seeing the membrane under the metal roof, and what your thoughts are regarding that. And I did look up the melting point of the membrane, just about 400 degrees.
Yeah, it's not great. So you get a firebrand on that roof and it's hot enough, or let's say you have like pine needles that build up on the roof, and that happens, leaves, or around the gutter, then definitely that can go right through the metal. And so that's the difference between a class rating, fire rating for a material and for an assembly. So code works largely with assemblies for larger multifamily projects, but for residential, it's mostly just the materials rating. So it's hard to, so there's kind of two different worlds in a way. That's an unventilated roof. So hypothetically, if that did catch on fire, that it might be treatable by not going into the structural assembly of the house very easily. Right. But it
doesn't propagate.
Yeah, but maybe you can talk to Intello and make a fire resilient vapor, open, the
Well,
perfect materials are still, there's still building science to be done.
right. Well, yeah, there's still materials. What about at the edges, the eave edges, the openings? How are you dealing with those to keep the embers?
Those are not ventilated, so that's just
You seal it up.
sealed up. Yep. No need to ventilate it, in my humble opinion. Somebody proved me wrong, but man, I know code has some weird ideas about ventilation that don't make sense for the high performance assemblies. So
Right.
you're kind of, I wish I had a straight answer for that. I wish that code and physics and fire resilience, all those things sometimes are in parallel and sometimes they don't track. So it can get complicated in a hurry. So
Yeah. Speaking of the ventilation and
or
there's
just
a question.
insulated. I'm sorry, Ken, we can all just throw some mineral wool up in there in those empty cavities if you want to.
Right. Well, I think filling the cavities, I mean, that's the interesting thing about the assemblies, looking at the materials, looking at the assemblies and the performance of them to make sure that we don't have any air movement that's possible in them. I think one of the things that speaks to passive house is we talk about all the time is, you want one vapor control layer or be smart about how you're doing your vapor control, but you can have as many air tightness layers as you desire. Ideally, we have an inboard air tightness and outboard, wind tightness.
Right.
And so you are creating a situation where you don't have air movement in that wall, which could propagate, and where you were talking about the insulations, and depending on the densities, you could have air movement. So there's that double air tightness that works well for the assembly in terms of moisture, and insulation also helps with the fire.
No, that's a really good point. And I should probably start drawing that wind barrier as a continuous from the roof through the eaves down to the wall, just like we do for the interior air barrier. That makes a lot of sense.
Right.
Yeah.
Yeah.
I haven't thought.
And there was a follow-up question, I think, saying, I'm not sure I quite understand it, but so a layer of gypsum board is not required all around above grade. So I guess the non-combustible material around the house.
Yeah, you can do that. I don't know if that's money well spent if you're using other materials, but
It's not required.
It's not required. That's good to point that out. That's an assembly. A lot of people do that because then they can just not think about these other kind of conditions. And I don't have any problem at all with that. I think that's a good idea, but just don't let the budget for that take away from other conditions where your house is vulnerable. So
right,
just making sure that you don't build the perfect amaze balls wall and then forget about your roof eaves and your windows and kind of other conditions. Yeah, it doesn't give you permission just to slather a bunch of wood or screw up your form factor or whatever else, or the plantings outside, things like that.
Right. On ventilation, there was a question regarding additional filtering outside the air intake. So we obviously have filtering for the fresh air intake.
Yeah. So we're stuck mostly with the Zenders for the residential units here for certified passive house components, and the Zender filters are completely inadequate for fire smoke. So
what comes standard with the system?
Which comes standard with the systems, but it's pretty common. I mean, you can buy just a 16, make a box or build a box, or have your installer install a box that just uses MERV filters, MERV rated filters that are just off the shelf, 16 by 20 inch or whatever whatever works for you, and just make sure that's air sealed or well gasketed going in. But that's definitely, I think there's a lot of room for improvement on that side to make it easier. And make sure that your units are not up in the attic, that they're easy to get to. Even if maybe the filters, that probably won't work for passive house, but make sure that you can get to it, because they do clog up pretty quickly in fire events in summer. I think people
Yeah,
are,
I mean, changing your filters is another passive house fundamental that needs constant reminding and renewing.
yeah.
You
I
cannot
think,
walk away from your ventilation system.
yeah. I know the Vancouver nerds have been like sharing some of their filter results from these fires.
Yeah.
In BC last summer. So
I mean, just in a city environment, you have
I know.
you need to change more regularly. With the smoke, with the fires, yeah, it's astonishing how quickly it can go.
So if anybody,
Thank God it's keeping it out of the house.
place for somebody to invent like a box with a sensor on it that just beeps, like when it knows it's filled up, and as an aftermarket thing, I'd put them on every house I design.
Absolutely, that makes a lot of sense. So we're over time here, and we should go in a moment. But I was just kind of wondering about your kind of personal journey. I mean, you were pretty young when that Oakland fire happened, I presume, and then living through these fires in Colorado and seeing, embracing passive house design and these different methodologies. I don't know, just in terms of your personal journey, I mean, it's now embedded into what you do in a way that it's like gravity, right? We call passive house or energy efficiency a new gravity.
It's like gravity. There's no way. It's like, once you start doing passive house, there's no way you go back and take a job that they just say, hey, just do a code plus house. And like, there's no way. You just get a passive house regardless. I can't help it. And the same with the fire. I do have a project in New York. I'm like, oh my God, I can use wood. I have a weird feeling. I'm kind of salivating a little bit at that. But yeah, it's like it's just because it's an emotional response. When you smell smoke, it's an emotional thing. We've been evacuated probably half a dozen times from my house. I've spent total time evacuated, probably like 2 months from my house because of fire. Tim Ian was actually, his family were at our house, and they got to see what it looks like when a giant wall of smoke comes at you.
Oh, he was there when that happened.
He was, and his family. So, that's an emotional thing. It's sort of like when you build a boat and it sinks, you're going to build your next boat so it won't sink. It's the same thing about fire.
Yeah, it's a good metaphor. There were a couple of things that I missed asking here. So one was a title question on 3D model that you're using. And are you generating fire-related data in terms of like vulnerability or anything like that, or it's just the principles?
I'm not really the data guy. The guy who first, the thing that's the design pH model. So that's what we design in SketchUp, all the preliminary. And I'm sure there's going to be a design pH course someday coming up for network, right? And I love that program. I use it like religiously. Even before I get a job, I typically do a quick schematic PHP to see what it'll take to do. It's great. So as far as like data concerns, I'm not really the building science data collector type. I would like to see people doing that. Hopefully the Vancouver folks there's some nerds out there who are doing it. The guy who did it in Canberra, I always mispronounce that town. I remember talking to him a few years ago because he presented at the Passive House Australia conference, and he's data logging the bejeebus out of his projects. It's fascinating to see just like when he uses his air conditioning, during these heat waves, or IAQ and all these other things. So it's incredibly useful to get like these, even though he's across the world, his data collecting is incredibly valuable and shareable for all of us. So
It's like we say, the physics is the physics, the heat's the heat, right? And the smoke's the smoke.
Yeah.
The one final question here, I think, best resource for determining fire-resistant building materials. Is there such a resource out there for?
Yeah, well, I know that most materials
rating?
have to have a fire rating on them.
Mm-hmm.
Want to do it for the exterior. So that's
So
good.
the catalog cuts of the material from the manufacturers.
Yeah, exactly.
But is there some kind of compendium or that you've seen?
I don't know of one that just particularly just calls out its fire resilience. Probably, I don't do commercial jobs, so I'm sure in the commercial world there's plenty of that fire rating resources that are based on the fire resilience.
Right. I think based on the fire, I mean, thinking about fire rated materials and non-combustibility and the burn risk and everything, fascinating the kind of scenario of having a concrete building and still have the entire contents of the house burn out. And really presumably a false sense of security.
Yeah, and I should say that there's a difference between fire survivability and a lot of code is really based on fire safety, getting people out of the building before it collapses on them. That's a lot of what code's based on. And also for those fire ratings, I think you'll get a lot of smoke emissivity ratings so that people aren't overwhelmed by smoke during a fire event.
Right.
So those are fire safety and life and safety compared to survivability of the structure itself. So think of those as separate kind of paths in that sense.
Yeah.
So
very good. There was a mention in the chat on a database in California in the state department of materials and assemblies that meet their code.
Okay.
So I guess it sounds like California is at the forefront in terms of the building codes around fire.
Yeah, I mean that the state's burning down.
Yeah.
All the time, and we've seen that happen to me and my family. You know, this is something they know.
No, it's been going on for a long time. Yeah.
And as we saw at the beginning of the talk, is that they're seeing vast improvements, 40% improvement from 1990 to 2008 in survivability of buildings simply by basic fire code changes. So it shows how incredibly vulnerable houses were back then,
right?
And that it's very treatable, but there's still a lot of room to grow in this. I feel like, and passive house is kind of the next step in that evolution.
No, that's amazing. It's just pretty straightforward handful of steps and have such dramatic effect on safety, public safety.
Yeah,
it's amazing. All right, well, this was terrific, Andrew. Really appreciate it. Great presentation. We look forward to putting this presentation online. It will be available probably starting next week sometime. And please let everyone know and share it. Really super useful information, and unfortunately is only going to become more and more useful as we go forward. So I hope to see everybody in a certified passive house designer course coming up, whether you're in Colorado, New York, Massachusetts, or elsewhere. And please join our other events. So thank you everyone for coming. Thank you again, Andrew. Have a great day. Bye-bye.